coefficient, this is AK. Now consider the signal X alpha t, where alpha is greater than 0. Can you tell me what is this operation? X alpha t?
So time scaling.
It is time scaling. Is it expansion? If alpha is greater than 0, is it expansion or compression? Sorry? What is, for example, what is x3t? Is it expansion or compression?
Compression.
So compression.
It is compression by a factor of 3. Alpha. So we can generalize this for alpha greater than 0. It is compression by a factor of alpha. Now let's see what happens to the Fourier series coefficients. If xt is having fundamental period t naught, what is the fundamental period of alpha t? X
So
alpha
that
t?
should be alpha greater than 1 for compression, right?
Oh, sorry, it is alpha greater than 1. Okay. It is alpha greater than 1. Okay. So, okay, here we consider alpha greater than 0. That means we are considering both the cases, either compression or this expansion. Okay, alpha greater than 0. So x alpha t, what is the fundamental period of this x alpha t? Will it be a periodic signal? First of all, we have Fourier series coefficient. We can have a Fourier series representation only if the signal is a periodic signal. Is it a periodic signal? If we expand or compression by a factor of alpha?
Yes.
Yes, sir.
It is a periodic signal. What is the fundamental period of that signal?
T naught by
Not
alpha.
by
It is T naught by alpha. Is it? T naught by alpha. Okay. So we can have a Fourier series representation with respect to that T naught by alpha. Because if it is having fundamental period T naught by alpha, we can always have a Fourier series representation with respect to that. Let's say this is Pk. And look at these properties here. These relations, like one is Fourier series with respect to T naught, that is AK. Its fundamental frequency. I am defining Bk as the Fourier series coefficient of x alpha t with respect to T naught by alpha. Now let's see if there is any relation between these two Fourier series coefficients. What does it mean if x alpha t are having Fourier series coefficients with respect to a fundamental period with respect to fundamental period T naught by alpha? Does it mean that we can write x alpha t as linear combination of bk e to the power j what? 2 pi by alpha by T naught by alpha? Is it 2 pi by okay, so it is e to the power j 2 pi T naught by alpha. Is it? Is it the fundamental frequency of the signal? Its fundamental frequency is 2 pi by T naught by alpha. So its fundamental period is T naught by alpha. So its fundamental frequency is 2 pi by T naught by alpha. Is this the expression for x alpha t in terms of its Fourier series coefficients? Do you agree with that?
Yes.
Now, what does this mean? Xt Fourier series representation with respect to T naught, its Fourier series coefficients are all AK. Does it mean that xt is k from minus infinity to infinity ak e to the power j 2 pi by t naught, because we are considering Fourier series with respect to period t naught. Kt, is it that?
Yes.
Now, if you put in this expression, we will get a relation x alpha t is equal to what? Sigma k minus infinity to infinity ak e to the power j 2 pi by t naught k alpha t. Is it that?
Yeah.
Now look at these two equations. Let me look at these two expressions and this. Are the same? Left hand side is the same, isn't it?
Yes, sir.
So right hand side also must be same. So tell me, what is the relation between AK and BK?
AK equals to BK.
BK is equal to AK. Is it that?
Yes, sir.
So what is the property? The property is that if Fourier series, if we have a periodic signal xt, let's say its Fourier series with respect to its fundamental period t naught is ak, then if we consider any signal x alpha t, where alpha greater than 0, then what? Its Fourier series representation with respect to which period?
T naught by alpha.
T naught by alpha.
T naught by alpha, that is same as what? AK. Fourier series coefficients will be remain the same. Is it the property?
Yes.
That is what we have proved. So here you have to be careful about the period with which we are taking the Fourier series representation. One, in the case of xt, we are considering t naught, its fundamental period, and x alpha t, it is t naught by alpha, and it will be ak. And x alpha t, we can find the Fourier transform with respect to period t or t naught also, isn't it? Is it possible? Is it always possible? It is possible only when?
Alpha is greater than 1.
Sorry?
So
Alpha?
alpha is greater than 1.
Alpha is greater than 1, and it should be an integer also, isn't it?
Yes, sir.
It should be an integer, then only it makes sense. Okay, so those things you can see those things.